Okay, freeze that window. Throughout this presentation, I'm going to introduce you to a number of people. This guy is Ralph Stacey, organizational theorist, probably best known for something creatively titled the Stacey Matrix. All right, here's what that looks like. On two axes, you've got how you want to do something versus what you're going to do. And it ranges from the center of where everything's crystal clear to where I have no clue. Right? And the way he defined it is, obviously these problems are simple problems. I know what to do and I know how to do it. Out in the northeast corner, this is unknown. This is the world of chaos. This is process of discovery work. And everything in the middle is complex. I want you to remember that word complex, because a little later on we're going to talk about the difference between simple, complicated, and complex. All right. So NASA, everything they built was designed to operate in that upper right quadrant. Right? They had, the science wasn't known. It was unproven at best. Their problems were the most complex kind of uncertainty. Everything had to be invented. Everything was custom manufactured, custom designed and manufactured. Multi-million-dollar artifacts were unavoidably destroyed in testing. Because human life was at stake, there was zero risk tolerance, so there was a breathtaking labyrinth of internal controls. Budgets were measured in millions of dollars, teams were measured in thousands of people, and your steering committee, well, that's the US Congress. That's where they were operating. What did we do? We self-inflicted. We said, well, geez, this is how they put men on the moon. This is how we should build our ERP system. This is how we should build our payroll system. Right? No matter what kind of problem we had, we applied that same measure of rigor and formality to it. We self-inflicted. Because that's what we do. So, all that stuff I just covered, the systematic management from the railroads, the Frederick Taylor with scientific management, systems management from NASA, it was all accumulative. Nothing went away when the new organizational solution was developed, right? It just all piled on. It all became huge. And that was last seen in the 1960s, and that is where we have stayed. Structured product development methodologies, very linear, highly risk adverse, pseudostatic environment, highly resistive to change, and highly structured project management, built to mitigate risk of the highest kind, to accommodate oversight by people unfamiliar with the underlying science and technology. Anybody relate to that? And in highly political environments. Now, in honesty, we have done a lot to tweak and tune that stuff, but it remains relatively the same. And if you remember right, history has taught us that there are one or both of two things drive the need for new organizational solutions: advancements in technology or expansions in organizational scope or span. And since the 1960s, have there not been ungodly technological advancements, and have geographic barriers not been eliminated altogether, that we're still using the old way? Let's look at those changes in technology in that geographic span, because you need to understand this and why it's agile. I'm going to introduce you to a guy named Alvin Toffler. He's futurist. He's the guy who predicted things like narrowcasting, media fragmentation, the internet, working from a wired home, things like that. He's futurist. He's best known for something called the Toffler curve. Anybody heard of the Toffler curve? It's shorthand for the concept of the accelerating rate of change and its effect and its disruption to humans and society. It's not the acceleration of change, it's the acceleration of the rate of change. And so from the time of Adam, or Lucy, depending on how you think at this stuff, you go on, and he divided it into three ages. So you've got the agricultural age, which goes to about, these are approximately the 1800s, followed by the industrial age, followed by the information age. He's the one, by the way, that gave it the name, the information age. All right? And to give you an example of change, so from the time of fire was invented till the invention of the wheel, that's measured in tens of thousands of years. By the way, the wheel's not the big invention. The big invention was the axle, but that's a topic for a different time. All right? The distance between the invention of the wheel and the printing press was thousands of years, not tens of thousands of years. And from the printing press to the telescope, it's hundreds of years. If I'm living prior to the Enlightenment and I want to study a predecessor society, that is a society that's working with technology different than I have right now, I have to go back 1,000 years. After the Enlightenment, if I want to look and examine a predecessor society, I got to go back hundreds of years. Today, if I want to examine a predecessor society, a society that has technology prior to what we have today, how far do I have to go back? A generation tops. Right? That's the accelerating rate of change. And the thing is that today, that line has gone vertical. The rate of change is no longer accelerating up this line of ever increasing slope. It has gone vertical, it is ever present, it is environmental. If you do not think it is environmental, let me ask you this. So, cloud computing, mobile computing, social media, they landed not too long ago. Think about how those changed not only how you live your life, but how your organization serves its customers, how your organization serves its employees, its vendors, the community, that sort of thing, the public. The Internet of Things is landing right now. Virtual reality, artificial intelligence, cryptocurrency are on final approach. Have you given any thought to how this is going to change how you live your life? How your organization serves its customers, serves its employees, serves the vendors, serves the public? You might want to give that some thought. Because that's not stopping. That's headed your way. Okay. Now let me throw in price factor equalization. Price factor equalization is an economic concept that says if you do not sufficiently differentiate yourself from your competitors, and if your competitors have the same access to materials and goods as you do, and in today's internet-connected world of global markets, they do, and if your competitor has the same access to capital as you do, and with global internet-connected capital markets, hell, with crowdsource funding, they do. And if your competitor has the same access to labor and talent as you do, and with global interconnected labor markets with the ability to outsource anything and everything, they do, then you will work for your competitor's wages. Let me give you two examples. This is true on both a company scale and an individual scale. So my kids will tell you on an individual scale, when they were graduating from high school and deciding what they wanted to do for a living, what's the advice everybody says? Well, pick an industry. Well, do something you love, right? Okay, that's one side of the coin. Another thing you got to think about is how do you want to live, right? But here's the deal. There's two things you have to offer a prospective employer. Higher skills or lower wages. Pick one. That's it. That's price factor equalization at work. Works on whole industries. In the 1960s, the US owned the consumer electronics market. Then Japan decided they wanted to get into it. And the US industries, they worked on a 15% margin. Japan wanted to get in, they started low, they started with transistor radios. And they worked for 8%. And the US consumer electronics industries said, do they want to compete with that? No, that's really the low end. That's, the money's all in color television, that sort of thing. So they retreated from the transistor radio market. Japanese then moved to desktop or countertop radios. Same thing. Then they moved to black and white TVs. Then they moved to color TVs. And the US companies made a systematic retreat. Today, there is not a consumer electronics company based in America. We gave that whole industry away. That's price factor equalization. Now add the internet in hypermix, where anyone anywhere can connect and interact with anyone anywhere, and they can do it at the speed of light. And we can move data of all kinds, right? It's not just money. We can move fear, we can move joy, we can move pleasure, we can move geographic locations, we can move property of any kind at the speed of light. That speed interdependence of events in today's world is going to eventually overwhelm everything. The things that have been reliable constants are going to turn into variables. And this highlights the difference between simple, complicated, and complex. I'm going to dive into this just a bit because it's a concept you need to understand. Now I'm going to introduce you to Dr. Warren Weaver. He was the VP of Natural and Medical Sciences at the Rockefeller Foundation. And in the 1950s, he published a paper in their annual report defining 3 stages of development. And this is where he came up with the stages that specifically relate to our ability to solve problems. You need to distinguish between simple, problems of simplicity, problems of organized complexity, or what we now call complicated, and problems of disorganized complexity, ones that we now call complex. So simple problems, 2 or 3 variables, right? In the 17th, 18th, and 19th century, this is what we worked with. And we could solve those. We learned how to solve this. And it was great because it gave us a theory of light, theory of sound. We invented radio, we invented telescopes, right? We invented telegraphs. We do it. It was great. But it hit its limit. Problems of organized complexity or complicated problems are those involve systems that have many parts, but there's a relationship between the parts, a linear relationship between the parts. So like if you look at a car engine, yeah, there's a lot going on underneath the hood and it may be confusing, but I can break that down into its finite components. And I know that if I alter this component, this is going to happen. Or if you got a financial investment, pays 5%, you invest $100, you're going to get $5 back. If you invest $200, you're going to get $10 back. It's proportional. You can predict that stuff. It's a linear thinking problem. These are all linear thinking problems. But then we have problems of disorganized complexity, or what is referred to simply as complex. Simple, complicated, complex. They involve billions of variables. More important is the fact that those variables are all interrelated. Okay? And the number of interactions between the components increases dramatically. And because of all those interactions, we are now in the world of nonlinear thinking. Take the game of chess. Okay, it's a rule-bound game, right? Every piece that you got the board, every piece has its own rules. At the start of a game, there are, I think the combination of moves are like just under 200,000. By the time you're at the 3rd move, the number of possibilities rises to 121 million. Within 20 moves, it's probably likely you're playing a game that's never been played before, because there are that many possibilities. More importantly, a small change at the beginning, like if you moved your pawn from A3, instead of moving it to A3, you moved it to A4, that changes everything. It's going to have large consequential results from doing that. It's just like the fluttering of a butterfly's wings. Hang on to that. So, disorganized complexity, complex systems. Ecosystems are complex systems. Ecosystems of all kinds, the economy, the markets, Mother Nature, the weather, the human body, international relations, civilizations and cultures of all sizes, including that of your organization. This is bringing new world sciences like quantum theory, emergence, chaos theory. And it requires competence in holistic, nonlinear thinking. This is something very new for our genus. Now let me introduce you to Edward Lorenz. Eccentric mathematician at MIT, early 60s. He's trying to figure out if he can predict weather. He's using the latest computers of the day, and he's thinking that he's trying to apply Newtonian principles to his weather prediction results. And he's working on it, he's not having a lot of luck. One simulation, he runs it, and he needs to rerun it again. So, but it's a big deal, right? It's on these old computers, the algorithms were pretty complex. And so he stops the one, he has it print out the results. What are all the registers showing right now? He has it print them out, and he says, okay, I'm gonna let it run. I'm gonna start it up again, but I'm not gonna start at the beginning. I'll manually enter those registers into the second one. The deal is with computer technology at the time, data was stored out to 6 digits, but they're only capable of printing 3. So when it reported the results of those registers, the contents of those registers, it reported 0.506, and that's what he entered. The trouble is what was actually stored was 0.506127. That was the difference between the wildly different results in his simulation. A rounding error of 0.000127 led to dramatically different results. Now, in a linear Newtonian world, that would have maybe meant missing our prediction for a lunar eclipse by a couple of minutes one way or the other. But predicting the weather, totally different results, because what he learned is tiny eddies of air can be influenced by an even imperceptibly small event, like the flutter of a butterfly's wings. And it will change the larger currents, which affect the way the air warms and cools. We're talking climate science now. All right? And those things could go on and start causing problems, even larger problems. A couple of years later, he wrote a paper, which the title of the paper is, "Does the flap of a butterfly's wings in Brazil cause a tornado in Texas?" And this is how the phrase, the butterfly effect, came into the world. And it represents the phenomenon of tiny, small changes being able to compound on each other to create tremendous results, have tremendous effect. This is the world we live in. So, we have all this history, we have all this psychological evidence and other evidence-based reason tells us that our capacity to predict the future is limited and becoming more so. Yet, we remain undaunted, because our history and psychology and our own experience also tells us that our capacity to believe our predictions is also unlimited. We should not. Maybe none of this applies to you. Right? Maybe the projects under your command aren't really $90,000 worth of meetings and $10,000 worth of real work. Maybe problems that you need to resolve or the opportunities that you get to leverage, maybe those are relatively predictable. Maybe they arise with comfortable, sufficient notice or come at a comfortable speed. Maybe they give you ample time to address them. Maybe that's no problem. Maybe the dynamics of your environment are comfortably manageable. Maybe reality shows proper respect for you and your plans. Maybe when you make plans, God doesn't laugh. My guess is that's not true. If you think that, this is probably you. It is the leadership challenge of perhaps an imperceptible, incessant, unrelenting, unpredictable change. You won't notice it day to day, but if you look back 6 months or a year, the trend becomes pretty evident. VUCA is the new norm. That's the bad news. The good news is if you know how to operate in a VUCA environment, it presents great competitive advantage because other people are still trying to figure out. You cannot chase customer requirements. You now have to create customer requirements to which potential competitors will have to respond. Right? To do that, your organization has to be able to deliver value quickly and frequently. You have to be adaptive to change even late in the process, and you have to be able to do it in a way that doesn't crush everybody and wear them out. You have to be able to maintain a sustainable pace. So what I'm saying is Agile is the new organizational solution for prospering, for competing successfully in a VUCA world. Those systems, the organizational solutions that you've been using before, the mashup of systematic management, of Frederick Taylor scientific management, of systems management, that accumulative effect, that's going to kill you. It will not keep up. In fact, I bet it's already started to kill you. That's how come the hamster wheel is going so fast. It's the need for the new organizational solution, and that's why you should be interested as an executive, as a leader. That's why in that first survey we saw, they are interested. That's the why. One footnote here. It is not uncommon when I give this presentation to others, people who think, well, I run I can see how this applies to a business, but I'm an internal service provider, or I'm IT, or I'm legal, or and I don't see how that applies to me. If you think that, if you do not understand that even though you're an internal service provider, you are still in a competitive situation, if you don't understand it, your era of decay and decline has already started. You're not entitled to your company's business. They can outsource you. They can replace you. They don't need you. There's a zillion ways to do the things you do for them. So, yes, you are in a competitive situation.